So I'd like to explore the relationship between a parent class and a child class. Both terms are also synonymous with a base class or a subclass. The parent class is also called the superclass, which is actually um, which actually derives a key term that we'll need to be interacting with in order to solve some problems. And so if we had, suppose we had a parent class, which I'm calling person, and we had a child class, which I'm calling employee, which is nothing but a specialization of a child as we go down into the hierarchy. But if we had a parent class, we understand that the child class can sort of inherit the methods and instance variables which are sort of encapsulated within the person class. So if I had, let's say, an int age, and I had a method which allows me to sort of speak, or allows the person to speak generally, and within this block of code, I'm just going to signify the speak functionality by just saying speaking. So this, I mean, just the instance variable age and the method speak is equally accessible to the employee, although nothing is in the employee class. And so creating an instantiation of the employee with its default constructor, and then referring to the speak method, which is found in the person class, and also referring to the instance variable, both of this, I mean, both things are completely valid, just because both things are completely valid just because everything within the person or the parent is accessible to everything to the child. And so I'm getting an error here because although there is an inheritance relationship, there is but a potential inheritance relationship. I must, of course, I must use the extends keyword to make it apparent that everything within the person is accessible to the employee. I use the extends person because I'm sort of affirming that I'm extending everything which is in person and not anything else. And so now, of course, I have no errors, but a missing brace. And so when I print this out, I get speaking and 0. 0 is sort of the default value for a integer if it's not initialized, which of course I would have to do with a constructor if I wanted to. This just goes to show that both methods and instance variables are very transferable to a child class from a parent class. However, if we had, suppose, a string name within the person class, could we in fact use a person constructor and sort of make that transferable to an employee? Well, the answer is no. Constructors are in fact not considered members of a class, and so they're not transferable to a child class from a superclass. You can see here that we follow the traditional approach of sort of making a person constructor, passing in the value of a name, and setting this .name equal to the name, that is to distinguish between the local variable and the global variable, setting them both equal to the same thing, such that one can equate to the other. We get an error here because we actually can't use this constructor. It cannot inherit the person constructor. And so there seems to be really no way that we can make this name accessible to the employee anymore, which is actually why if we create, like before, an instance of the employee class and do e.age, we find that e.age is not resolved, whereas before it was accessible. Or rather, I think name would be accessible, but we couldn't really set name to the same thing that name is set in. We would, if we were to set a name in the employee class, it wouldn't be the same name that we're referring to on the person inside the parent class. And so essentially the way to counter-react that is to sort of use something called the super keyword, and I'll show you how. So first things first, what we could do first is we can use a extends, not extends, but we could use a constructor for the employee. And what this would allow us to do is we could load the constructor with our own personal variable called string name. And now essentially what you could do is you can say, well, you can call the super function, and what this super method, this constructor, what this would do is it would go into the person class and sort of search for an existing constructor which passes in a string. And I would do this by essentially passing in a string. What this does is, again, it goes back into the person class because it extends person. It would go back into the parent class and search for a method which contains something or some constructor which takes in the value of a string. And so as you can see here, the string that we've sort of made, which we are making unique to this particular block of code, essentially now applies to the constructor that we see on the person or parent class. And so this allows us to sort of tinker with name as if it were the name which we find on the global level, the name which we find on the local level, and this dot name which equates both of them to one another. And so now what we can do is we can actually just print out, the employee name. Now recall that we actually can't use a print statement out in the open. We actually have to put this into a method, which can be a display. This is completely fine. However, so now what we can do is we can actually go back into the sort of the main method here, and having already made an object of the employee class, what we can do is we could load this with a name if we wanted to, and this would essentially allow us to print out employee name. So we actually have to call that method. We can't just blatantly, so we have to call the display method in order to make this applicable. And now we can print the employee name. We could do the same thing with an employee ID, and this would be done very similar to the way it was done with the string name variable, where we used the this dot keyword. So we would have a name, but we would also have an employee ID. And we could just say this dot employee ID is essentially the same as the employee ID we're referring to. We're getting an error here because we actually can't use super as the second statement. It has to be the first, and that is the only way we won't get an error. And so now at this particular point in time, both the name and the ID are accessible to the employee class. And so going into the display function and actually just printing out the employee ID in conjunction to the employee name, we find that this is perfectly applicable. Going back into the method, we find that we're getting a red error because whereas our constructor in our main method is only taking in a string, we have highlighted or made it apparent that not only are we going to take a string, but we're also going to take an employee ID. And so not doing so is problematic. So we can sort of make a random ID here, and then doing the display, we would understand that we would get both the name and the ID. This is, of course, a very odd way of giving a user a ID and a name, or a name and ID. And so what we can do instead is we can make variables, which of course we'll have to prep up. Now, this would start with making a scanner, which is actually just going to take in the input from system.in, or the console for that matter. Then we ask for the first name. After entering the first name, we can make a first name known to the scanner. Next line helps us print out the complete line which the user would enter. And so now we have both a first name and an ID. Doing so, we've loaded first name and ID, both of which match our scanner names, into our employee constructor. And in string ename and in employee ID, both refer to, well, only one refers to the particular class and one refers to the superclass to which it refers to, and then it loads this ename into this name and makes that name equate to this name and this name and this name. And so essentially here we're actually referring to the same thing, and we've been granted access to this particular block of code. Printing this out, gives us a favorable circumstance.